who's a professional engineer with extensive process and project management experience in commercial, residential, and industrial sectors. For the last 12 years, he's been directly involved in the design and implementation of sustainable buildings, energy efficiency, and high-performance mechanical systems. During his career, Will has worked as the environmental manager for Michelin North America, as the lead faculty in the Nova Scotia Community College's Energy Sustainability Engineering Technology Program, ESET, and currently is an active faculty member with both the Canadian Institute for Energy Training, which is CIET as an acronym, and the Canadian Green Building Council, which I think is up there. No, the acronym's at the bottom there in the large letters. Anyway, welcome, Bill.
Appreciate it, Helen. Okay, thanks very much. Can everybody hear me okay? I'm just going to do a couple of quick tests. Perfect. Okay. I'm not used to being mic'd, so I'm going to slide that back here. Normally my voice carries far enough. Can everybody, I guess, online hear okay? Do we have any feedback, or is that just by text? We're good? Okay. So today I'm going to run you through a modified version of the Zero Carbon Building Standard, which was developed by the Canada Green Building Council. And so one of the things that we see a lot of times in the marketplace is this confusion around zero. So net zero, is it net zero energy, net zero carbon? This is a standard that applies to both new and existing buildings, and it's meant to really draw our attention to go, you know what, it's not enough to just simply go, let's carve down energy efficiency and make the buildings perform more, but we have to actually give consideration to where the other carbon is. And we'll go through all the different levels and the life cycle components of where that carbon comes from. But this, again, is meant to kind of cover the broad strokes of what the program involves, where it's going from a marketplace perspective, and then what are the kind of the key considerations that we need. Has anyone in the room ever heard of a LEED building? Okay. So LEED is I'll call it a sister if you want, a brother. LEED was developed by the US Green Building Council, and then Canada would adopt it and kind of make it its own, right? We say, well, some of the stuff here is a little different. Obviously, we don't have a Florida in Canada. We're a little bit northern, so they always kind of adopted this. The ZCB, or Zero Carbon Building, is made in Canada by Canadians. It was actually one of my students, Finn McDonald, who actually worked on developing this after he left the ESET program. The beauty of this versus the LEED is that it's very much dialed in and simply focused on carbon. Okay, so if we go through what the LEED standard's really about, it's looking at things like water efficiency, building efficiency, indoor environmental quality. So there's a little bit more of a broad stroke, big picture. What is the actual impact of the building? This one is laser focused on going, where's the carbon? How do we chase it? How do we drive it down? Does that make sense? A little bit of limited liability. I definitely don't read this whole thing. CAGBC owns this. It's their rights. So again, I've provided a PDF version of the slides for a takeaway, but it is copyright material. So please don't reproduce it. If I see at another church presenting my presentation, we're gonna have problems. Myself, Helen gave me quite a nice introduction. It's always tough listening about yourself in front of a crowd. But I started my career as environmental manager in the Waterville plant. I actually started a little earlier in Granton. I don't know if you folks know of the Michelin plants, obviously a pretty big employer. But I walked into a kind of a big mess of, we're renewing our environmental operating permit. And surprise, a plant of 1.6 million square feet has a couple concerns. After that, I left Michelin. I moved into the NSCC, where they said, we have this brand new 2-year program. Here are the classes we think make up the 2 years. Good luck. And that was a July hire with a September start for students. So it was about 3 or 4 years of, I used to actually have slightly more hair, as you can tell, up top. But I left that program because I was starting to turn out graduates into the industry that was actually starting to evolve, at which point I created and started Equilibrium Engineering. In that time, from my time at the NSCC to today, I have been an instructor with the CAGBC for over a decade, CIET, Canadian Institute for Energy Training as well. We've developed and delivered courses around management, energy modeling, carbon literacy, building envelope design. We're currently working with the province Department of Natural Resources and Renewables to build out some new training for the evolution of the low carbon economy here in Nova Scotia. So love doing this stuff. I don't have to take away any assignments, which is kind of nice. And when I'm done, I'm done. I will be moving around. So if I'm blocking anybody or if I'm having a hard, put your hand up. From housekeeping, I would much rather you put your hand up and have a question before we go further. Don't have to hold them. We can make this a little bit more interactive. So if you're not catching a topic, shoot your hand up. We can discuss it out. There's probably a couple other folks in the room that are having the same, I don't know what he means. So in terms of the objectives, ideally, and again, this is slightly modified. This is usually delivered in a 5-hour set. So we're going to go fast and furious a bit, like drinking from a fire hose, if you like. We'll talk about why focus on a carbon and building standards is important, and specifically to supplement and firm up Canada's climate change goals. We'll identify the major components of the zero carbon standard itself. How do we record it? What do we have to report? What do we have to prove? What don't we have to prove? And we'll ultimately talk about this idea of a zero carbon balance. Anybody want to take a stab at what that might be? With the building's perspective, what do we see as the big carbon sources? Concrete would be one. Okay. So there's a piece of our material. We call that embodied carbon, right? Older building like this, all the embodied carbon has kind of been spent. We've already paid for it, owned it. It's sitting in the building, right? We talked a bit about energy. What about that? That consumption profile, right? My electricity, my fuel oil, maybe I'm natural gas. So as I consume, I have my operational carbon, right? So often from a marketplace, we've always been hyper-focused on the operational piece, right? Turn it off, switch it, LED, heat pumps, let's go. But we've ultimately ignored a lot of the embodied component, which is basically like saying, I don't care what's happening in front of this side before I pick the item up at Walmart or at the Home Depot, right? But there's a whole bunch of carbon associated with that, with things like digging the materials out of the ground, sending that to a manufacturing plant, making it into something, putting it on a truck. Now it's at Home Depot. And then on the backside of going, well, what happens when the building's at end of life? Well, it goes to the dump. There's carbon associated with that demolition, the transportation, and ultimately the recycling, reusing. So this piece is really about opening up the focus on carbon and not just focusing on energy. Does that make sense? Let's talk about why we're zeroing in. Long-term goal is ultimately to keep the global average temperature well below 2 degrees C, above pre-industrial levels, and to pursue efforts to limit the increase by 1.5. This one may be a stretch. I read an article actually yesterday that says it looks like we're on track for 1.5 by about 2029. Kind of, I don't want to be the doom and gloom show here, but there's some stuff here where there's an acceleration and there's a bit of a momentum that it's not like stopping your car and going, we're good, right? There's impacts that are already in play that will continue to be in play until that think of that spring bounces back into the middle. Now, in terms of our targets, so we'll be taking, be kind of mirrored up if you want to look at like NOAA, the NASA, that would have satellite data. It would be collection from the Stanfield Airport plus the Kentville weather station. So they're using composites, and then they would also be using satellite imagery and other items to collect that. So if you look at NOAA, for example, that's doing all that atmospheric analysis in the US. So they would be groups of scientists in different countries and regions around the world kind of tracking that. The bigger one I find often is this one here, right? This pre-industrial level. Let's go, well, where are we talking? Are we talking, pre-World War I? Are we talking pre-machine? That target seems to move. I think in Canada, we use 2005 levels, right? So it's a matter of saying, what's the baseline and how do we get to it? Does that make sense? Nope. I know. That's what I'm saying is that there is a moving target on what we call our baseline, right? So they go, well, we're going to establish these pre-industrial levels. Obviously, 2005 was well established from an industrial perspective in Canada, at least. So it's a matter of the government's agreeing to go, here's the line in the sand. We're going to say, if we go back and get our records, these are our emissions from that period. Now we have to beat those emissions going forward. So in Canada, the intent, and it started out as a 30%, so a 30% reduction by 2030. And that's again below these 2005 levels. Since they signed that at the Paris Accord, they actually doubled down and said, well, maybe it needs to be 40%, right? So we've already rewritten the requirement after we first signed the document. If we go a little bit deeper, there's other groups out there like the World Green Building Council. They're actually suggesting that all new construction be net zero operational carbon, i.e. all my energy to the building to operate it, with a 40% reduction in embodied carbon. We'll get more into the embodied carbon, but the challenge with that is pretty significant. So if you think about a device like this, probably, I'm going to guess 100 different materials, right? So if I took every one of those materials and said, I'm going to trace that back to where it came out of the ground, then where it went to a factory, and then where it was shipped, and then where it was actually put together, to do the life cycle analysis to identify what the embodied carbon is for this device, which is multi-component, would be very, very difficult and take a lot of time. Now, if I were to compare that and say, well, that's a piece of stud wood that I bought at Home Depot, homogeneous, one material, pretty easy to do the math on, right? So the industry is catching up on doing the math on all the materials. And if you've ever been to a Home Depot, you've seen that there's quite a few bits and pieces in a 40,000 square foot store. So if you think about that, even looking around this building, you know, there's an embodied carbon for the ceiling tile, the flooring tile, these metal posts, the drywall, et cetera. So understanding that the call it the manufacturing side hasn't caught up to that yet. And the best way to think about it is like, if I go to Sobeys and I pick up the can of Campbell's soup, I can look to the back and there's the ingredients. We don't have that in most cases for materials. And that's where the gap is. Beyond that, they said 100% of new buildings, 100% of buildings, both new and existing, to be net zero operational carbon by 2050, and 100% of new construction net zero embodied carbon. These are swings for the fence, right? And the challenge is here and here, those seem like long times, right? But to actually move the industry, we were meeting, I think it was 2 weeks ago, we sat down with HRM. We have money, we're trying to retrofit all 240 of our buildings. How many have they done so far? Couple, right? City of Edmonton has 3,500 municipally owned buildings. They're doing 35 a year. So in 100 years, they'll be done, right? So it's the pace at which we're doing it. It's the way that we're doing it. It's the ability to break it down and go, how do we do this faster? And if you think about it from your organization's perspective, how long would it take? If I came today and said, here's the price to do all the new envelope all over, maybe a solar heat pump package. Okay, now you have to raise the funds, get it approved by the board, and then actually have it done. It's probably 2 years, right? So if you think about that from the existing stock of buildings we have, that's a pretty big challenge. So why now? Well, buildings built not to be zero carbon today, ultimately you're going to have a pretty significant capital investment before we hit 2030 and 2050, right? So really the idea is we should be doing these things upfront today, becoming code, becoming mandatory. The reality is that mechanical systems or lighting systems are relatively simple to retrofit if they've been designed for low carbon futures. Building envelopes, much tougher. How old is this structure? Anybody know off the top? 100? 80? They say 80 years old, right? When was the last time the whole building envelope and all the windows were replaced? Probably never, right? Maybe some window repairs, right? So if you think about it from that scale, the stuff we build today doesn't make a lot of sense that we're probably going to be retrofitting before 2030 or 2050. So why do we consider carbon as the metric? Well, it looks at all things like the carbon intensity of different energy sources, okay? So we think about that. We're always beating up a little bit on gas and oil and fuel heating. And then we go, okay, well, electricity. And then someone goes, well, hey, you live in Nova Scotia. Your grid's actually pretty dirty, right? Because we're base coal with a bit of cogen from gas, right? So we're not the cleanest grid. We're actually probably one of the worst grids in all of Canada. So understanding that every fuel, every type of energy we use has a slightly different amount of carbon it puts out, GHGs it puts out per unit that we consume. Make it more difficult. I buy a liter of gasoline or I buy a liter of home heating fuel, but I buy a kilowatt or I buy a gigajoule of gas. Anybody know what those look like? Yeah, they're weird units, right? So unless you're an engineer, it doesn't make a lot of sense to the common everyday person. Carbon also encourages the use of renewable energy, energy storage, and innovative solutions. That's a piece of it. And again, I use this turn of phrase all the time. I can take any building and make it net zero energy. Any kind of crappy old building with enough solar panels on it's net zero energy if it's all electric. Does that make sense? Doesn't make it a good building, right? I mean, could be inefficient. It just has every surface covered with solar panels or maybe a wind turbine outside. Not the right solution. Promotes a shift towards low carbon materials, which I would say today isn't really a big option, right? If we look at the downtown landscape in Halifax, steel and concrete, right? We're working with a client right now that are looking at doing a 12-story, I think it's 12-story wood frame structure. So heavy timber wood down in the Dartmouth side. And so that'll be the first one in Halifax of that size. And as you can imagine, that's where we're going to start to see some pretty significant embodied carbon savings, because now we're taking something that has sequestered carbon, putting it into material into a building, and then using that instead of, say, steel and concrete. Steel's not as bad as concrete because a lot of steel is highly recycled. One sec. Concrete is a bit more challenging. It's typically a ton of concrete, it's a ton of carbon, right? So we're getting better. We're figuring out different mixtures to use with that, but ultimately it's still pretty intense. It would be very high also.
Could you repeat the question so online people can hear it?
I certainly would. So the question was, we know that concrete and steel are relatively high intensity embodied carbon. What about glass? Well, glass is also, again, as you can imagine, taking sand, heating it and melting it to make glass, also very high intensity. And so when we did a little project when the Ecology Action Center put their third story on, that's one thing we actually looked at. We ran a life cycle analysis and said, we have some older windows that have been salvaged and used. And we looked at them and said, okay, well, maybe they have 5-10 years left in them. If we put in a new high performance, triple glazed, way better window, higher quality, does it pay? And the reality was it didn't pay at the time, right? So for some of those things, we have to wait to a natural end of life where we actually need a new window because it doesn't operate anymore or it's broken when we have to make those replacement decisions. So it's a bit of a challenge because we're also, as North Americans, pretty attuned to, I didn't like it, it's not the newest model, what do? I go buy another one, right? That's the culture. Now, when we talk about this idea of whole life cycle, this is often where we interact, right? This is literally Will going to the store at the Home Depot on that dash line to pick up the new insert X, drill, piece of wood, saw, whatever it is. All the effort or all the carbon that was created from energy of extraction in the product manufacturing, the construction, happens before, right? We don't consider that. We're kind of like horses with blinders from that perspective, right? We get the product, that's great, it serves my purpose, and then we use it, and then we get rid of it. Does that make sense? So when we're talking about products and we're talking about materials, we really have to start to consider that whole life cycle, that cradle to grave or cradle to cradle. Now, in terms of the benefits of zero carbon, and again, some of this you could say is a bit of marketing, but the reality is that there's reduced risk, obviously, to asset value. So one of the big pieces we don't play a lot in from the economics are what happens when Fiona comes through and the government has to bail out $1 billion, or what happens, we saw 2 years ago in Texas, never freezes in Texas. Well, guess what? It froze and a whole bunch of buildings, multi-billion-dollar damage. Is that idea of resiliency of the asset, right? We have reduced life cycle costs through operation and maintenance savings, okay? Good selection, good materials, proper plans, put it in play. And, you know, an older building like this would have a much higher operation and maintenance budget because you're always kind of keeping the old ship fixed, if that makes sense, watertight. Meet climate leadership objectives collectively. So again, doing our part. Drive innovation, economic growth, and the jobs of tomorrow. I would say that to some extent, the jobs that we have today really just need a slight tuning. So how do I retrain that electrician or that HVAC person or that framing carpenter as an example? Doesn't mean it's a full new job. It means we have to give them some extra tools for their tool belt when they go pick up projects or when they're designing stuff. Improve comfort, health, and productivity. there was an interesting study I saw. I think it was the Empire State Buildings. They did a deep retrofit and they spent a huge amount of money, did all the systems, new glazing, new glass, big chunks of envelope. And what they said, they looked at it and they said, here's the old energy budget and the new energy budget. And they were big numbers, you know, like small country type numbers. But then they showed the amount of dollars that goes through that building in the daily salary of the occupants. And guess what? It was massive. So that idea of having comfortable buildings where I'm comfortable, you're comfortable, you know, Chris doesn't have a space heater over in the corner cranking up because he's freezing, right? That idea, we spend most of our time inside buildings, right? So we want them to be healthy, safe, and obviously comfortable. Last but not least, protection against energy and carbon pollution prices. We see this a lot with people building new buildings. They go, well, I have a budget and it's all about what I call the first cost, right? I need it to cost this much. But they don't look at the cost to operate it. They don't look at the taxes. They don't look at the, you know, how much I'm going to spend on electricity, maybe how much I'm going to spend on fuel. Sometimes spending 10% more up front could save you 25% more in the operating costs, which are costs you pay every single year. And guess what? Nova Scotia Power is going to continue to do this, right? All those of you that watch The Price is Right, like the yodeling price guy, and they go up and down, but ultimately it's going up, right? We'll see little drops here and there, but at the end of the day, prices are not going to go drop out of the bottom, right? So what we're seeing today at the pump, what we're seeing today at our electricity bill or our natural gas bill, those numbers are going to continue to grow. Plus you add inflation on top of that, guess what? Everybody's pinched. So let's talk a little bit about the standard. Comes in two flavors or versions. The first one is the design. So this is for brand new buildings or major retrofits or renovations of existing buildings. Next to it, its cousin, the performance standard. This would be for, say, a building like your church. So I can come in here, I can certify to a zero carbon standard operationally from your church, and the programs are different. As you can imagine, what I'm doing in this design standard is a little bit more tailored around what types of systems am I picking? How's the envelope look? Have I done a good job of mitigating or reducing some of that embodied carbon? Whereas this one is, you've got a structure, you've already kind of earned or burned the embodied component. So now how do we improve your operational component, if that makes sense? In an ideal world, a brand new build would come through here and certify, and then they move into this performance. The beauty of the performance standard is that it is annual. So the CGBC doesn't like it, but I use the term. It's like, you've all seen those cars. Maybe it's your friend. He's got that 1983 Toyota hatchback wagon that looks like it just rolled off the line and there's 200 rust check stickers on his window, right? That's the idea. The maintenance is this performance side is we want you to continually be looking at how your building performs and continually certifying, because we want to see that ultimately drop, right? Does it have a cost? Yes, both programs have a registration cost and a certification cost, okay? So it's all done by square footage and size. In terms of the zero carbon building, a zero carbon building is a highly energy efficient building that produces on-site or procures carbon-free renewable or high quality carbon offsets in an amount sufficient to offset the annual carbon emissions associated with the building materials and operations. So that's a real mouthful, right? A zero carbon building is one that's not net zero energy. It's one that says we have bills, we add them up, we go, here's this much gas, this much electricity, times the emission factors for those, gives us a total bucket of carbon or GHGs, greenhouse gases. We now offset that either with on-site or purchased renewable or carbon offsets. Makes sense? So it kind of gives us three pathways. Obviously, this one is an ongoing cost. So about 4 years ago, I did some work at Chalk River Nuclear Site, and it's about 300 buildings on this property on the Ottawa River, and massive. And they were looking at this, like, how do we get our campus to zero carbon? Huge gas plant, as you can imagine, district steam pipes running everywhere. And the reality was, because they're federally mandated to be reductions, they were looking at a pretty heavy purchase of carbon offsets for the next 50 years. And guess what? That wasn't in the budget, right? That operational carbon, that buy it for eternity, didn't exist. So they had to start to give some consideration. Say, okay, as we make renovations, here's what we suggest you do, right? All new construction, here's what we suggest you do. But the challenge is that not all scenarios will be able to just go to zero carbon simply by putting a panel on the roof or 1,000 panels on the roof, if that makes sense. In terms of the key components, we have obviously carbon and energy. Both of them are pretty much handcuffed, right? Just depends on which type of energy we're using. From a carbon perspective, projects must account for and eliminate carbon emissions across the entire project life cycle. So that goes back to that slide I showed you with the dashed line, right? We have to consider what happened up front. We have to consider what happens when we're done with the item. From an energy perspective, projects must demonstrate superior energy efficiency. Some metrics have thresholds and some are for reporting. And we'll talk a little bit about the metrics. They have a brand new one that they use. I think that's pretty smart, but it kind of fights what we consider for most building envelopes, which is that idea of the R value, right? Everybody's heard of that. I bought an R24 bat, or I blew an R60 to my roof. They've moved into something called the thermal energy demand intensity. It's really about going, how does the building lose heat? How does it gain heat from free passive solar, et cetera? So it's looking at the whole thermal bucket and going, how do we do this better? Lastly, the impact and innovation. Projects must incorporate impactful, innovative technologies and design approaches, and they're customizable to the project. And I'll show you through that list. Again, for those of you who have seen the LEED building, LEED has 6 categories, plus specialties, plus pilots. This is focused on really 3 things: carbon, energy, innovation. Okay. It's slimmed down, trimmed down. It's meant to be fast to implement, so it's easy for the marketplace to adopt. LEED, from a perspective, for those of you who don't know, leadership in environmental and energy design, was designed ultimately for about 10 to 15% of the top performing buildings in the world. So as you can imagine, most of the developments going up around here, we're not seeing most of them being LEED Platinum. You know, the folks that are really doing a bang up job, Dalhousie University, right? They have a lady named Rochelle Owens, and she's an absolute champion at pushing that, but she has a directive and she's the head of sustainability for a relatively large organization. A lot tougher when you're a grassroots organization like a church going, we don't know where to start. So this one, I don't expect you to have all the answers, but it's a good opportunity to have a little breather from me talking. What do you think are some of the key challenges associated with using carbon as the primary metric? Right. What's a ton of carbon look like? Right? Is it this much? Is it this much? Can I pack it in my trunk? Right? We don't have a good idea. We don't have it's not like grabbing an apple or an avocado at the store, right? It's kind of generically, I don't understand what it is, right? What else? Anybody at home? Oh. Okay, I apologize. Got it.
Nothing from home.
Nothing from home, okay.
When you talk about carbon, you talk about carbon dioxide or carbon?
We're talking really, we use carbon dioxide as the proxy. We're really talking about greenhouse gases. So what's the problem, I guess, of using an emission type metric for buildings? So one answer was, we don't understand it. It's not easily definable, right? What about regional differences? So Quebec, as an example, is almost 100% renewable on their electricity grid. Massive hydro, right? So if I did a project that said, okay, let's electrify in Quebec City, I'm going to have massive greenhouse gas emission reductions if I've displaced any fossil. If I do that same project here in Halifax, and I said, okay, I've got a building that recently upgraded their boiler to be natural gas, which is one of the cleaner fuels from a fossil fuel perspective, and I flip that over to a straight electric baseboard, guess what? The emission factor on Nova Scotia's grid is going to actually probably increase the output of greenhouse gases. Now, if I do that with a heat pump, which has a much higher performance than an electric baseboard, maybe I might be even. But the reality is the regional difference or the regional variation in grid density on how much carbon is emitted or how many GHGs are emitted per kilowatt hour that I purchase is drastically different. Okay. Anyone else think of any questions? Yeah.
What's in it for the organization to go for the certification? We can see what's in it to control your energy, but
Yep.
to put a client that says I'm carbon near zero certified, what's the What's the payback? What's the advantage?
That's always the challenge. I think part of it is one, a social group like yourself, as an example, is doing the right thing, right? So lead by example. We hear that all the time in my market, which is, well, Canada is such a small emitter compared to everybody else. It doesn't mean we can just sit here and do nothing, right? Because we are, comparatively to say China, or comparatively say, the largest oil company in the world. Yeah, we're a tiny piece of the global emission, but it doesn't mean that we can do nothing. And from that perspective, if you think about it, why are the emissions in China so high? Well, it's because North Americans are consuming massive amount of goods that wouldn't be manufactured if there wasn't a market for someone to buy them. Does that make sense? The plaque, I agree, it's a plaque, right? Doesn't mean really much to a lot of folks. The reality is that means that you're committed to incrementally improving the performance of your building, and that's really what it justifies. The other thing is that regardless of whether I get my sticker or not, it's a standardized approach to tackle the problem that allows you to say, here's my pathway. I can do this without having a will on our board, and I can make this happen relatively simple. Does that make sense? Great question.
Quick comment on that. One of the problems I see in zero carbon, zero energy, net zero energy is where do we start? We have a big challenge, and we could use every engineer, technician, technologist, and trade person we could possibly employ to get it done. We have to get the big gains first, I think.
100%.
Is this part of the big gains first? Or?
This is definitely part of the big gains first. So the question for the folks at home was really about, this is a big elephant to chew up, summarizing. Where do we start? Where do we take the first bite from? The reality is that if we don't first benchmark and baseline what we have, we're never going to know, right? So we can say StatsCan every year does an analysis to go, this is our global or our national emission factor. To understand where that lives, you can easily go, well, it's in this much goes to Nova Scotia and this much goes to Quebec and this much goes to New Brunswick. That's still pretty not very granular, if that makes sense, right? We actually have to start to dig in. And so something like this, which actually just starts, and I'll use the performance pathway, it simply starts with 12 months of data from your building. So that's a good thing. Obviously the person who cuts the checks for the church understands how much you're spending, but do most of the members understand what they're spending, right? So it's about saying, let's draw a line in the sand, let's take a look. And if you look at Nova Scotia, I'm just going to make up a fictional number, say there's 10,000 buildings. Ideally, what we want to do is sort them all first and go, which ones are the crappiest, right? So let's take the ones that have the biggest potential to make big savings from, and we'll knock those off first. And then we start to go down the line, right? There's no point. We did some work for, say, Steel Auto Group. They were looking at trying to green their portfolio, if you think about it. And so we said, here's the approach that we would take. We'd take all your buildings, we benchmark them, and then we're going to pick the worst 5, and we'll go in and do energy audits. And they're like, well, we'd like you to look at the Audi dealership. You're like, yeah, it's shiny, but it's also 5 years old. So when I compare that to something that's 25 years old in Middleton, Nova Scotia, as an example, wasn't a great choice, but it was done somewhat for the optics, if that makes sense. Mm-hmm. So the reality is that we need to establish baselines, and then this kind of program allows us to easily baseline and understand where the line in the sand is and how do we take that first step, whether it be a 10% reduction or a 20% reduction. Great question. So let's talk a bit about this. You caught me before we got here on the carbon. So we use carbon as that term, but carbon includes all greenhouse gases. And these obviously aren't all of the greenhouse gases out there, but there's some of them. The ones in this lighter green are what we would call naturally occurring. Okay, these are things that are already existing in the atmosphere. That's our carbon dioxide, our methane, nitrous oxide. The orangey colored ones on this slide, and for those of you at home, the grayish colored ones, these are manufactured. Nitrogen trifluorides, sulfur hexafluoride, perfluorocarbon, hydrofluorocarbon. These are things that we use either in manufacturing, in our heat pump gases. These are things that humans have constructed. And the reason why we use this idea of carbon is we've got to draw it all back into a common unit, if that makes sense. So something in one of these guys might be 1,000 times as strong. So I could have one carbon, but one nitrogen trifluoride might be 1,000 carbons equivalent. So what they're looking at is trying to go, which ones have the highest impact but then having that multiplier effect. So if I lose 1 kilogram of this stuff, that's like losing 1,000 kilos of this. So it's trying to create it as a common denominator, if that makes sense. Now, when we talk about the idea of the zero carbon balance, we're really looking at net emissions. This is the hardest math that we'll do all day. We have our embodied carbon, which is the upfront carbon, our use stage carbon, and our end-of-life carbon associated with the materials of the building. We add that to our operational carbon, which is associated with our direct and indirect energy consumption. And then we subtract our avoided emissions, our exported green power, or those carbon offsets that our organization purchased, right? The intent here would be, and again, going back to that first slide of 2050 target, would be that this plus this minus this is always zero for every building in Canada. We're way, way, way not close to that. I know that sounds, again, a little bit gloom and doom, but to get to where we need to go, we're going to spend a lot of time and effort in the next decade spending on carbon, developing new renewable assets, and slowly improving this operational carbon by making efficiency investments in our buildings and our systems. Now, in terms of the standard, and again, the standard is what the standard is. Under the design side, you must model a zero carbon balance. So we have, I think, 4 projects right now on the go. And when we model, what we say is we're doing an energy model. So I take plans from the architect, plans from the electrical and mechanical engineers, and we actually create a simulation of what that building will do if it was operated 9 to 5 as a church or as a shopping center. We take that, and that gives us our operational carbon amount. We then also take the shell of the building and we break down all the materials, take off all the quantities, and we calculate that embodied carbon component for a 60-year life cycle. We put those together and that gives us the information. Now, to get our quote unquote sticker or plaque, we must provide a quotation for any carbon offsets. So we must be able to prove that we could, if we needed to today, purchase enough carbon offsets to offset the amount of embodied carbon here and here. Does that make sense? So again, it's not requiring us to do it today. It's saying that we need to understand where the components are so that we can start to think about purchasing as we go. Under the performance side, you must actually achieve a zero carbon balance in operations. So for the church, as an example, we would add up your, is this fuel oil, I'm guessing, with the radiators or natural gas? You have a boiler though? We've got a fossil fuel driven heating system. So we would add up all the consumption of that, multiply it by an emission factor, and we go, okay, there's 1,000 tons of GHGs or CO2 equivalent. We add up all your electrical, and we do the same thing. Under that performance side, you're actually required to offset that. So that could be, I participated in the Amherst Solar project, and I bought my power. There's a company called Roswell. They're a renewable to retail supplier currently in the province, the only other one. So they're kind of an alternative NSPI. I could go out and buy all my electricity from them. I could ultimately get on and just go, well, I'm not going to do either of those things, but I'm happy to pay the carbon offsets for that amount, right? So to go back to your question, starting about what's the value under the performance side, there's probably more value than there is under the design side today, because people are actually offsetting that operational carbon. So they're putting their kind of money where their mouth is, if that makes sense. Now, if you use green power products, you actually have to have purchase proof. So they're going to ask you to, it's kind of like sneaking out of Sobeys with a chicken dinner you didn't pay for. Do you have the receipt for that, right? They're going to want to see that you actually offset and purchase that 100,000 kilowatt hours or equivalent. Now, this one's super busy, and I'm guessing back there, it's really hard to see. This is why, to use my example, the mic, why it's so difficult to understand embodied carbon for components. These are all the life cycle stages that we would consider if we did an actual LCA or life cycle assessment. So you've got your raw material supply. This is all product stage. Transportation, manufacturing. This is my construction stage. This is my transport to the site. This is the actual construction process itself. This, in that tangerine looking box, is my upfront carbon, okay? So again, materials arrive on site. I've ignored almost all of this because I don't think about it. I just made the order to Home Depot. This is our operational carbon, our use stage. So that's the use of the building, the maintenance. Maybe I had to replace a window. I'm going to document that because the new window is going to have, guess what, some embodied carbon, right? I've got my repair, my refurbishment, my replacement, and then down here is my operational. That's my power bill, my oil bill, my natural gas bill. So again, looking at this from a life cycle approach, upfront, operational, end of life. And inside the end of life, we have the deconstruction or demolition, again, transport, because I have to take it from the site to a C&D site or to a dump, waste processing, then disposal. And then in an ideal world, in this hatch box, we would have our ultimately our benefits and loads beyond the life cycle. So that's our reduce, reuse, recycle, right? So now taking that material and say, okay, the brick that I chipped off your building when it was at end of life is now, I don't know, maybe it's chips for someone's garden, right? It's not just getting buried in the ground and thrown away. So when we look at that, obviously this embodied component happens pretty heavy here. So repurposing, reusing buildings or renovating them has significant embodied carbon savings because I'm not just going like most developers would, wipe the slate, build brand new. It would be maybe easier and nicer, but we're saving a whole bunch of carbon if we don't do it that way. Makes sense? Any questions there? That's a pretty busy slide, and hopefully the folks at home can probably see that a little bit better than you folks can, because that is very small print. So again, the zero carbon is really everything inside the red box. Have we considered this? Yes and no. So the beauty of the LEED standard and the zero carbon is that they evolve over time. So everybody's heard like the analogy of, you throw the frog in the boiling water, it's going to jump out right away versus you slowly turn up the heat and you will boil it. It's the same idea. The standards have to slowly improve over time so the developer and builder market don't freak out, right? If we said tomorrow that all buildings had to be net zero carbon, guess what? You'd have more developers in town hall, in the premier's office, everything would just be an absolute nightmare. So we incrementally move. And so, for example, this is the version 3 of the zero carbon. Version 1 just said you had to report embodied carbon. Version 3 says you have to reduce it by 10%. So they're slowly ratcheting these to get people used to it, to make it accommodating and comfortable so that we don't all lose our minds. Sure. Yep. Great question. So the question for the folks at home, what are we doing? What kind of progress have we made on heat recovery, whether that be heat recovery from water or air streams? The reality is that we've made some progress. National Energy Code for buildings now actually requires heat recovery for air systems. 2 versions ago, I believe it was just exhaust streams bigger than 150 kilowatts. That's like 10 houses. That's a huge exhaust stream, right? So now we actually have to have a minimum, I believe it's a 50% under NECB. Water, we're not doing a lot with. If you think about it, and we did this math, any of you know the Q-Lofts building down, it's kind of a Gottingen area. So that was one of my first clients, Peter Pauly, Polycorp, and all of his buildings are aggressive. That one was 75 or 78% better than Energy Code at the time he built that. All his Wolfville ones, same thing, 75% or better, because he goes, I'm going to own this asset for a whole bunch of years, so why wouldn't I want the operating costs to be low? I can also keep the rents nice and flat because that's predictable, and because my energy bill isn't the biggest cost of owning the building, right? So when we look at that Q-Loft, the reason why I bring that up is we did some actual analysis and said, if you took all the 72 toilets and showers and you averaged out how much people use, and then you actually capture that before it hits the black pipe that goes to the sanitary system, most of that water sitting, when you blend it all together, sitting at about 21 degrees Celsius. So if you think about what a geothermal heat pump is, it's I put a cable or a well in the ground, and I'm happy if I'm pulling water out at 5 degrees. So as you can imagine, if I have 5 degrees versus 21, big difference in available. So we actually, and I've never seen this with a developer, we actually went down to Rice's Concrete, which is in Bridgetown, in my end of the valley. And there's a developer who's owning multi-million-dollar buildings in a tank top, and we're strapping PEX pipe to what effectively were manholes. And then they cast them right in place, and he buried those under the building so that he could capture that and then overflow to the city. The reality was, because conventionally oil and gas have been cheap enough. Again, it's that first cost. Most developers go, I don't care, right? So in my industry, the biggest bang for the buck is when, unfortunately, the end users feel it in the pocketbook, right? That's when people actually react, right? My daughter is a good example. I drove her car here today because I blew a tire out on mine, but she has a diesel Jetta TDI. She's like, oh my gosh, $2.10. She was like, when I first got the car, it was $48 to fill it. She said it was almost $100 yesterday. So that's when people actually make action, is when you're impacting their bucket. So when you think about that from a wallet perspective, you think about from the developers, most developers don't plan on holding buildings long, right? They'll hold them until they amortize them, and then they either flip them or they do something else. So to build a cheap as possible code compliant building and then sell it to developer B, they've done their part. They're maximizing their profit. So until we have some regulatory pits, I'd say that's a real missed opportunity. Great question, though. Let's talk a bit about embodied, and I've been going through this a little bit as we go. We talked about it from the life cycle stage of upfront, use stage, which is that operation and maintenance, and then the end of life, what happens when we have to get rid of the item. Embodied carbon is the carbon emissions associated with the materials and construction processes through the whole life cycle of a building. Okay. So again, the blinders we typically have is we buy it. When it's end of life, I put it to the curb. Maybe someone takes it and repurposes it, but most often I wait for big garbage day and it disappears, right? How do we calculate it? Well, we do a full LCA or life cycle assessment that looks at resource extraction, manufacturing and transport, construction, maintenance and replacement, demo and disposal. And this is what they call cradle to grave. So the idea of I took it out of the earth, I made it into something, I put it in a building, and now it's ready to either go back to the earth or become an input as a raw material somewhere else, if that makes sense. When do we do it? Well, ideally, we do it as early as possible in the design stage. So the challenge with most construction projects is that once they get going and you have that permit, guess what? The owner and the developer, they want it to happen. They want the keys tomorrow, right? So if we've slipped past that and we haven't done a lot of this analysis, it's really hard to pull the lead back in and go, well, did we consider this? The other challenge that we see in this idea is, and to be less important to where I live than where you folks live, say in the city, is that when I buy a lot in downtown Halifax, guess what? I'm building right to the lot line, right? Because they're small and they're expensive. So I don't have a lot of opportunity to go, cool, can we shift this condo 30 degrees? No, because the concrete goes all the way along the invisible property line. We maximize every square foot. So some of the stuff that we could do, or the analysis say an Ecology Action Center would do on their new renovation, is way different or way out of the norm from what the regular market does, if that makes sense. Which buildings need it? Both new and retrofits. And then we use a 60-year service life. So that's a common service life for what we would call envelope construction, if that makes sense. So we run those numbers and we calculate them and go, here's how many tons of equivalent carbon or GHGs would be associated with building this concrete structure with the wood frame and the asphalt shingles. That makes sense? Question? Mm-hmm. Yep.
I can't imagine food trucks.
In and out.
City.
100%.
So I don't-
Yep.
And now. So I guess I'm thinking going way back.
That's a good question. So for those of you at home, the question was, how do we consider the site prep, the excavation type work, the civil or the earthwork? And the reality is we don't today, right? In that scenario, and again, this is where the standard evolves, we don't track that because it's too complex, right? And that is a mist, right? You think about all those little buckets of mist accounting for carbon, those are big ones, right? Because that's big equipment running 8 to 10 hours a day, running diesel fuel. They're not clean. They don't have the emission requirements that your brand new car has. They're just big chunks of gear moving soil, earth. And the reality is that the importance of something like a zero carbon standard allows us to at least put a lens on that. So you're now asking the question. So what we would anticipate would be the standard will continue to evolve. And at some point, yes, we'll go, okay, if we're building So I'm partners with Lindsay Construction, for example. Maybe they're building a brand new building. I want to see your logs of operating hours for that piece of equipment. We know how much fuel that consumes per hour. Now we're going to start to do that math. It's kind of like, it's the frog example. It's like, get them into the water and we'll start to ratchet it up, but don't scare them away yet. It is a huge missed opportunity. In terms of reduction measures for embodied carbon, so what can we do? Because again, I still need a foundation. I still need structural elements to hold the building up. So what can we do? Build less, making better use of existing assets. So I also own a little home building company, and we see this all the time. People come to me and go, here's what I'm thinking about from a plan. How much? We have a budget of 700,000. You're like, well, it's not going to get you quite where you want, right? But can we get it smaller? Right? If you think about that, and that's one thing the Ecology Action Center did very well when they redesigned, they're going, can some of these spaces be multi-purpose? So instead of having a 500 square foot boardroom that only gets used once in a while, and having another this space, another that space, how do we make that good design and go, now there's spaces that we use all the time. This building would be another example, right? How much time is spent upstairs in the hall versus how much time in the community rooms, right? So understanding that good design, if I reduce square footage, I reduce budget, bingo, great, I met the client's budgetary needs. But if I reduce size, I'm also reducing materials, which has an immediate impact on embodied carbon. Make sense? Reuse or repurpose existing structures. Again, if we can reuse it, we don't have to go out and get new raw material, manufacture, transport it, construct it. Use low carbon materials such as low carbon concrete mixes. We talked about heavy timber as another alternative. Again, some of these things take time to not only hit the market, but then a lot of, call it mainline developers, want to see somebody else do it, right? Before they're going to trial it, right? There's a lot of not what we call not early adopters out there, especially in that development side market. Explore the use of storing or sequestering carbon in materials. We're seeing more of that, but again, relatively small. But there is opportunity there. And then maximize the efficiency of materials used. So this was one for a long time. Advanced framing is a good example in residential. Most new houses that are built today are built on a 16-inch on center. Right? Advanced framing is a 24-inch on center. That simple change of distance between studs results in about a 9% reduction in wood. So something as simple as that, and going, there's better ways to do this. We just have always done it this way. And that's, very common in rural kind of setups, right? My grandfather taught my dad, who taught me to do it this way. That's the way we do it. Doesn't mean it's the only way to do it. This is an example. This is the Phoenix. It was a headquarters for LeMay in Montreal. So they were a retrofit of an existing building to achieve zero carbon building performance. They retrofitted instead of constructing a new comparable building, and they resulted in an 86% reduction in embodied carbon. So again, a high-end brand who wants to show they're environmentally conscious, did the math, and they said, you know what? Didn't mean the budget got any lower, but the reality is they repurposed an existing structure to meet their needs. And guess what? I didn't have to go to Home Depot to get all the materials fresh, if that makes sense. And again, a nice looking building. Not all buildings have to be boxes with no windows made only out of recycled wood, right? So let's talk a bit about operational carbon. Chris. Yes. Do you want to walk around? My pleasure. No problem. Yeah. No worries. Welcome back. Do a little herding of kittens or cattle. If we could all jump back in our seats. I'm probably going to have to go a little bit faster. So maybe what we'll do is hold questions for sections, if that makes sense. I'm happy to stay here as long as you guys want, but I'm guessing you all don't want to stay here all night with me. So let's talk about operational carbon, because this is what we probably have more association with. This is our direct and our indirect emissions, okay? And we'll break those down here, but this is the inputs we do to our buildings to have lights, to have internet, to have projectors and microphones. Operational carbon are the emissions associated with the energy used to operate the building, and that's all systems in the building. the elevator, the heating system, right? In a lot of cases, we think about heating and cooling as being the dominant. They're definitely the bigger loads in most buildings, but the reality is it all adds up. So ignoring it is not the answer. Now, in terms of breaking these down, direct emissions, and I don't know who came up with this, but they really missed the target here because they go direct and indirect, and then they throw in scope 1, 2, and 3. So it's super confusing. Direct emissions are things that happen directly on the site. So inside the property boundary. So your boiler, the boiler in this building is a direct emission. I literally burn or combust that oil. I make hot water. I provide heat to the building. An indirect emission is something that is coming, in theory, across the property line. So my power cable from Nova Scotia Power, if I'm downtown at Dalhousie, the underwater steam pipes that supply heating to all the buildings, those are what we call indirect. It means that the combustion and the emissions has happened somewhere else. So for you folks in Halifax, that's Tufts Cove, right? So the nice clean electricity I get out of my plug to run my laptop, well, that was some coal and some gas and a whole bunch of dumped thermal load to the bay. Now, when we break those up, that indirect can be further subdivided into energy indirect and other indirect. The other indirect, to go back to your question, are the things like cars coming in and out of the site or the construction site, right? So all those people that show up to work at the Halifax Shopping Center, those are scope 3 indirect emissions, if that makes sense. And again, currently kind of not on our purview. It's not something we're ready to dig into because everybody wants to be able to drive wherever they want, whenever they want. The other ones that we see in the direct side are leakage of refrigerants, okay? So everybody's probably has a friend or maybe has a heat pump. They make sense. They save energy. They have a high performance ratio. They use a gas, however, that has a very high multiplier for GHGs, okay? So that heat pump that you see rusting on the side of someone's building who's not doing any maintenance, and ultimately at some point it will fail, and they'll call and they'll go, my AC doesn't work. All that gas is probably leaked out and is now floating around in the environment. And because it has a high multiplier, could be equivalent of 1,000 times, 2,000 times the impact. Does that make sense? Because it's a very strong GHG. Here's an example. R134A and R410A. And again, nobody here has to be a gas expert. These are the typical gases we see in the heat pumps and the mini split systems that we have in play today. 1,500 times, 2,200 times. So 1 unit of that is equal to 1,500 or 2,200 times as much CO2 equivalent. Does that make sense? And that's why we put them together and call it CO2 with the little e, right? We're making sure that they're all together. Now, in terms of those indirect emissions, we talked about the scope 2, that's our purchase electricity, our district heating, our district cooling. Okay, so again, anything that's wired or piped over the property line to then be used, but the emission happens somewhere else, right? The other indirects are our scope 3, which are currently optional, but we would anticipate they would become inside the focus as we evolve or as we turn up the water on the pot, would be water use, waste, and then the transport. Again, pretty big impacts. We're just not ready to have 10 things to deal with at once. We need to deal with 1 or 2 things. That's just the nature of humans. So this one is, here we are, Nova Scotia, and that's down a little bit now. Saskatchewan, Alberta, Nunavut, we can cut them a break because they don't actually have a central distribution grid. So it's all diesel generator, right? So when we look at Nova Scotia, and this is around, I think, 680 grams per kilowatt hour, okay? So when we think about that, every time that meter spins, every time you pay for a kilowatt hour on your bill, there's an equivalent of just under a kilogram of carbon or GHGs emitted. If I were to flip over and go to Manitoba or Quebec, which are predominantly hydro, almost nothing. Ontario, Newfoundland, they sit around a 30. So again, the way I tackle buildings in Nova Scotia to decarbonize is completely different than the way I might do it in Quebec. If I wasn't worried about making, Quebec gas really mad, we could say we electrify all buildings in Quebec, the province of Quebec, and we would be massive reductions in GHGs. Would the grid hold it? Probably not today. Would the gas companies freak out? Probably they would lobby pretty hard, right? So understanding where we sit regionally impacts how we kind of approach stuff. So from retrofitting in Nova Scotia, we really have to say, what's the logical step? Because we know this grid number will come down as we add more renewables, but that's going to take some time, right? How do we reduce? Well, and this is what I've been talking about. This is our activity data. So it could be our gigajoules of natural gas, our kilos of refrigerant, our kilowatt hours, our liters of fuel oil. That's our consumption. How do we improve consumption? We apply efficiency, right? So turning off the lights is a good way, setting back the thermostat. Those are all things that reduce the waste, non-operational waste, which reduces how many units I have to purchase. From the emission factor, we take the consumption of it, we times it by that to get our grams or kilos of. The other ways we can look at that is go, maybe we switch, right? So we have efficiency plus fuel switching are kind of two of the biggest levers to reducing operational carbon. I was close. Yeah. So let's talk about renewals, because this is again, I've got no problem with these, and the challenge that we have with renewables is that they're shiny, right? So like the crow goes to the shiny thing. It's easy to go, wow, I've got solar panels. I've got an old house. I don't have solar panels. But I did spend $75,000 to strip all the siding, redo the building paper, put 2 inches of R12 on the outside, redo the cladding, right? Made the investment on the thing that gets the waste out first. Could I put solar panels on now? Sure. I've done my improvements. I got rid of the old, was probably a coal boiler, which was converted to an oil boiler, which was then moved into a heat pump system, right? So I get the waste out, then I go high performance, then I look at end of pipe, which is renewables. It's the end of pipe solution, right? Now, if I've taken an older building like this and I said, I've done absolutely everything I can practically do and I can economically do that makes sense. Now that starts to look a little bit different, right? So understanding what I can do, what has a price point, but at some point, the cost of going more renewables is going to cross, right? If I had to rip all the brick off this building, re-insulate it, put all new cladding on it, guess what? Probably not the best bang for buck, especially because the church only gets used a few times a week, if that makes sense. It's not like a hospital, which is 24/7. So those paybacks are different because the run times are different. School is the same thing. School's shut for 2 months of the year. So those savings potential gets reduced because I don't have people in it full time, 2 out of 12. Renewable systems, whether on-site or off-site, reduce the need for non-renewable, thereby reducing the emissions associated with these energy sources. In most cases, right? Nova Scotia Power is not going, well, Chris's solar panels are pumping today, let's turn the boiler down. Base load runs all the time, right? And then we run peak load devices to catch up with what happens when we all run home and turn on the oven at 5 o'clock. In terms of renewables, we also consider alternative fuels. Now, the CAGBC has gone out and done some research, said, okay, what makes sense here? Because again, there's a big debate in Nova Scotia, right? Point of Coney, Cape Breton, whole bunch of wood being stuffed in a boiler. Terrible use of wood, right? So we've taken something that is actually out there sequestering carbon, i.e. building it into the building blocks of making bigger trees. We're cutting down crappy wood and we're throwing it in a burner, of which is ideal efficiency somewhere around 38%. So we've taken all these trees, we've trucked them to a burner, we throw them in the fire to get some electricity out, and 50 or plus more percent goes out the stack or gets dumped to the water in the heat recovery cycle. So when they talk about alternatives, they say we can use biomass and biogas. Biomass has to be solid biomass removed from fields and forests that are managed by sound environmental practices. This is not clear cutting and Will making a bunch off the cheap land he bought in Bedeck. This is properly managed with a forestry plan showing that what I cut was replaced, what I cut was evenly cut and not just slash and burn. Dedicated energy crops with a rotation of less than 10 years. I am not a soil expert, but the reality is if you just throw corn in one field every year after year, you're gonna ruin the soil. There will continue to pull nitrogen out of that and there won't be any left. So you have to move crops so that the next crop that comes in maybe is fixing nitrogen, putting it back, and then I can bring corn back maybe 2 years later. Same idea though, we're having a hard time feeding people and the cost of food is pretty expensive. Should I be making fields of corn just to make ethanol to then make you feel slightly better about what you put in your car because I blended 5% of it with the gasoline, right? Maybe you just don't drive as much. Probably a bigger impact. Liquid fuels derived from biomass noted above, such as ethanol, methanol, or biodiesel. So again, there's some options there, but we're not quite there and we're definitely not at scale. Biogas, eligible biogas includes gas produced by anaerobic decomposition of organic waste from sewage treatment, manure, or other farm or food feed based, and then landfill gas. Those two have big potential. I don't know what the number is, but excuse my French, Halifax probably full of shit, right? There's a lot of it. So instead of having the debate about whether we treat it and then spread it over our food, or we maybe use something like an anaerobic digester to make a product that could be made into energy, might be a smarter play. The other beauty of that is that we already collect it all kind of at a couple key points, right? It's not like going out and picking up dog poo from your yard and then carrying it to the store, right? It's all comes to one spot already, so that mass collection is a lot easier. It makes a lot more sense. Landfill gas, a little bit more challenging. If you think about the one that's just past Sackville heading back towards the valley, you know, smells terrible. Most landfills are built not anywhere near anywhere, right? Because nobody wants them in their backyard. So that decomposition that's occurring at that landfill might make lots of potential fuel, but it doesn't mean it's close to anything that can use it. Does that make sense? So we either now have to figure out how to trap it, compress it, or transport it, and then deliver it somewhere else, which again has a carbon impact, right? So trying to marry some of these up, you know, putting a landfill directly beside a Michelin, huge win, right? Let's take that. You guys are going to use all of it. So perfect. Make a pipe. Renewables. Projects have several options: owned renewable, on-site, or virtual net metering. So again, can I put it on my roof? A lot of roofs aren't suited. An older church like this probably could take some solar, no problem. Older, if you look at like Burnside as a good example, older steel and structure, probably not great for a ballasted, weighted system, right? Virtual net metering is the idea of going, well, I know there's lots of land down by Will. Why don't we put 5,000 panels in one spot close to a distribution grid that doesn't cost a lot of money to interconnect with, and then use that everywhere else. This is kind of like your net metering here, right? In Nova Scotia, we are allowed to do virtual net metering as well to accumulate. If I were, again, Peter Pauly with Polycorp, I own a couple of buildings. I could accumulate from an accounting perspective all the consumption across my buildings, and then have one asset that generates enough to offset these 10 assets as an example. That's your virtual net metering. You also have what we call green power procurement, so power purchase agreements, bundled green power, and renewable certificates. Again, these are more comparable, at least these last two here are more comparable to buying kind of a carbon offset. A PPA, or power purchase agreement, is like me saying, I would like to own a piece of that wind turbine. I don't want to own a full wind turbine, but maybe I want to own 1,000th of a wind turbine. Or maybe I want to own 5 panels in that 5,000 panel field, right? That's a power purchase agreement. And currently in Nova Scotia, we don't have a real easy avenue for that. Doesn't exist. The only one that has a path right now is, again, it's a renewable to retail. Roswell is the only folks. They were originally the Scotia Windfields group. They've got a huge tract of land down by the old Brooklyn power plant down in the Liverpool area. So they're going to continually throw up big turbines over the next 10 years. And they're signing up people to say, if you want to buy all your electricity as renewable, we can sign you up as contractual. Does that make sense? Doesn't mean that you're ever getting an actual electron from one of those turbines in Liverpool. It just means that you're saying, I'm willing to spend maybe a ½ cent more per kilowatt hour to do my part and put my money where my mouth is. Maybe I'm a business, maybe I'm a Sobeys, you know what I mean? Like someone like that who's really trying to look at their profile. On-site, the benefits of include improved building resilience, reduce pressure on the grid, minimize environmental impacts, and increase distributed generation. This one can be true. The challenge is, and we would have saw this early, the folks that were really early adopters in Nova Scotia that put solar on their house, and they're like, well, when the grid's down, I'm going to have power. Well, no, you're not. When the grid's down, you have what's called anti-islanding, which means you have to shut that system off so you don't fry Chris trying to put your lines back together after the storm, right? So unless I was an off-grid or I had a hybrid inverter that allowed me to operate off a battery, which nobody had 10 years ago in most cases, unless I was off-grid completely, I didn't have the ability to be taking solar and using it in the building. The other challenge is that's a huge building. Do you think that 150 panels up there covers the needs of that whole building? No way, right? If you look at, anybody been to IKEA in Dartmouth? Massive building, right? That's a building that has a big enough roof that covers most of that load. But that's a huge building, right? And when we get into downtown Halifax, downtown Vancouver, downtown Toronto, guess what? The lots get much smaller. I don't have an IKEA sized roof downtown on Yonge Ave or any city in the Canada or North America. Reducing pressure on the grid means I'm providing some feedback. Utilities would probably debate that, right? They go, I don't want a bunch of trickling pipes feeding onto my pipes. I want to know where the big flows are coming from, right? Doesn't mean it's not, but this one's probably the biggest benefit, this idea of distributed generation, right? We all know what happens when the grid goes down in a storm. High priority areas get hooked up first, and then if you happen to be in the boonies, maybe in a week, you're good to go. Distributed assets are like the idea of saying, instead of having just a Tufts Cove and just a Point of Coney and just a Trenton, we've got assets that can generate in smaller grids. And I think this is what you'll see probably picks up more pace in the next 10 years. If I were a developer, example, making a subdivision, why would I just sell you the land once when I could sell you land and power, right? So that idea of having some assets there. We did a big battery project with the town of Berwick where we actually installed container-sized batteries at their arena and at their town hall. So now they can reduce their demand from what they buy from Nova Scotia Power. And then in the event of a storm, we can run pretty much that entire town hall library building with the battery. Is that an inexpensive tech? No, but like all things like VCRs, the first one was $1,000. The last one that came off the shelf was probably, they were giving them away, right? So the technology will change. Virtual net meter I talked a little bit about, but it's the idea of saying there's probably a place where the wind is better, right? Putting a wind turbine in my backyard just because I can doesn't mean it's a good value, right? So I want to put the wind turbine where the wind resource is the strongest. Likewise, I want to put the solar where the solar is the best. I can get the ideal orientation. I can get the right slope. I'm not impacting anybody else. Being able to do that means that we can generate or make bigger assets and then all kind of benefit indirectly without having to potentially own the capital cost. This is a success story in our local backyard. This is the Wilkinson warehouse. They were one of the original pilots for the zero carbon when it first came out. So this is Eastport Properties, Judy Wall. And Judy, as a developer, said, you know what? If I'm going to own these buildings and rent these out, I'm going to put my money where my mouth is. And the economics today make sense. So she invested in it. They achieved zero carbon design certification. They incorporated some on-site solar generation. The solar system was sized to meet the needs of the heating system. So they took a practical approach and they go, if you want to rent here in one of my warehouses, we'll include the heat. And guess what? We're going to cover all that heating cost with electricity. So you have just a rent bill. You don't have a heating bill if you work or rent from us. Owner is able to provide tenants with a $0 bill, which means they know exactly what they're getting. There's no variable cost from a month-to-month perspective, right? For example, at home, I use the budget amount for Nova Scotia Power just because I like to know that the monthly unit coming out is always the same. It gets reset every 12 months, but the reality is I don't want to see a $600 or $800 December bill when I'm trying to buy presents for the kids, as an example, right? So from a developer perspective, this is a person who's local, who is an expert across the country, and she saw the value economically and as a business case to say, you know what, we can do this better. I don't have to have just your classic kind of crappy Burnside metal steel frame concrete building, right? Now, in terms of green power products, I'll move through these quick because in most cases, individuals were not buying this style. The Amherst pilot was a good example. You could have signed up as a homeowner to say, I want to buy some of my power from that Amherst, and it would offset my GHGs. Relatively small bucket. It was a pilot, and it owned and operated by Nova Scotia Power. But that's the idea of signing up to a green power product, right? Someone's offering something that allows me to get the benefit of the environmental impact reduction, and I can do it whether it be for my own best interest or for my company, because my company, I also have to say, you know, we're doing the right thing as well. In terms of hierarchy, power purchase agreement is preferred over renewable energy certificates. with the utility green power somewhere in the middle. And again, I'm not going to get too much into these because contractually these don't exist that easy in Nova Scotia because we are primarily a monopoly. Does that make sense? If I were to pop into Ontario or into Alberta where it's a bit more free market, this would make more sense. We just don't have this here today. In terms of the types of products that work, solar, wind, water, biomass, geothermal. This one here also has a bit of a caveat. We talked a little bit about Quebec as an example, having a relatively low distribution intensity because they're all hydro. So again, to your question about understanding tracking the fuel in and out for infilling on a site as an example, well, hydro in itself is clean to generate power. The creation of the dam and the reservoir area is not, right? So if I bury, I don't know, 10,000 hectares of vegetative material, guess what? It's going to rot, right? And rotting things make what? Oh, methane. Methane has a higher multiplier than CO2, right? So we're not always looking at all the case from the perspective of what happens at the turbine. Yes, Quebec Hydro is very clean, but in terms of all the vegetative material that we buried, which will then decompose and ultimately be released, it's not a zero, right? Same idea with woodlots, right? Nova Scotia's got a history of woodlots. Woodlots, it's inexpensive. I can cut it. The carbon I'm releasing was already sequestered, so we call that net neutral. Well, I still had to put gas in the chainsaw. I still had to run the truck out to the logging site. I still had to put gas in the hydraulic splitter. You know what I mean? Like there's aspects of there where we can pretend, but we're not always being completely transparent, if that makes sense. Avoided emissions or emission reductions that occur outside of the value chain of the life cycle of building. Projects receive a credit for avoided emissions in their zero carbon balance. So again, we talked about that in the equation. That was the last piece. So this could be either a surplus electricity. So I made more than I needed and some of it went out to the grid. That's an avoided piece. Or maybe I actually went to the point of doing my LCA and said, okay, well, all that material that we demoed actually found a home and I can show that there's actual savings. That would be the other kind of an example of an avoided emission. But it's kind of like, how do I show? Wood's another good example, right? We don't look at the whole impact. It has a lower embodied carbon when we model it, but when we go full stream, obviously wood can go right back into the earth, easily recyclable, is what I'm trying to say. So that's our exported green power. And then the last piece is really our carbon offsets, which again, serve a purpose, but we can't rely on them, right? When everybody wants carbon offsets, guess what happens? Anybody here study economics? Supply and demand, right? So we're complaining now because the feds implemented a mandatory carbon tax in Nova Scotia. That's going to ratchet every single year. So that's going to get higher and higher and higher. Well, if tomorrow everybody like the Walmarts of the world, the superstores, the Sobeys, they all said, well, you know what, we're going to go out and buy all the carbon credits because we're going to be good corporate citizens. Okay, that's $60 a ton that we're paying. Looks like a really good deal because now they're seeing $300, $400, $500 a ton, right? I was in BC for the Build Green conference, which is the national conference just before COVID hit, and the feds were already modeling $400 to $600 a ton. Now, does that impact us downstream? Not yet. You know, the $60 a ton definitely does if you hit using fuel oil or you drive a car. But the reality is that, you know, if everybody just relies on that as a solution, the cost of those is going to go way up, and the supply of them is, guess what? They're still also limited, right? Now, in terms of the avoided emissions specifically to the standard, we can offset indirect emissions with extra renewables sent away. Does that make sense? I can't offset the emissions associated with burning oil in my burner with my extra PV. I can only offset electricity for electricity, if that makes sense, under the standard. Now, in terms of carbon offsets can be used to offset both direct and indirect emissions, which means I can use it to offset the burning of oil in my boiler, or I could use it to offset the associated carbon from Nova Scotia Power supplying me electricity down my line. Does that make sense? Now, when I look at this the intent of a carbon offset is ultimately that I've reduced emissions somewhere else and somebody's able to benefit financially, saying I did a good thing, I implemented a project, maybe it was, I don't know, maybe Michelin did something, go here, I just saved 1,000 tons. I can put those out on the market. You know, maybe Chris wanted some and Will needed a couple, and maybe the province of Nova Scotia bought the rest, right? The intent there is to incentivize folks that are early adopters to say, well, you're already putting your money where your mouth is. If we can validate and verify that these are legitimate savings, why shouldn't you be able to sell them out to the market to somebody who needs them, right? Now, a carbon offset can be used to offset embodied and operational, both direct and indirect. So they're kind of, that's the bit of the downside. They're kind of like that trump card or the joker, right? Now, with that being said, buying a carbon offset for 1 year doesn't actually reduce the energy consumption, right? That building, if you've done nothing to it, is still going to have the same carbon output next year. So you're going to buy these in perpetuity, right? Which does not have a really good case, right? Financially. And surprisingly, the market responds to that. The other thing we want to make sure is that they're high quality. So additionality, permanence, and leakage. So what we don't want is, and I'll use the, maybe it's the young kid who's got the weekend job of delivering flyers, right? Oh yeah, I put out 5,000 flyers. Did you get the 5,000 mailboxes, or about 3,000 of them in the dump, right? Same idea. I could go in and go, we'll have a great piece of land. I have 508 acres in Badek, and guess what? I'm gonna have someone come in and put saplings. Yeah, that'll eventually create carbon savings, but if I put in 10,000 saplings, do you think all 10,000 survive? No. Does a sapling take as much carbon out of the air as a mature 50-year-old oak? Definitely not, right? Just mass. So we have to understand that these things have to be legitimized, they have to be validated, and they have to be maintained. The other things we don't want is this idea, right? So I bought some carbon credits, any developing country in the world, right? Maybe I sent them some smokeless fire pits. Maybe I did something like this, right? We do a very poor job, especially in North American culture, of going, well, as long as it's not in my backyard, I don't really care, right? I was listening to a CBC article on the way up today about cobalt mining, right, in Congo, and you're going, well, some big battery companies are making out very well extracting cobalt. Congo's not, right? So again, understanding that we don't want to just switch our emissions somewhere else and go, well, and I'll use this example. Michelin Waterville goes, I'm going to close down. Our annual emissions were 10,000. I'm just making up numbers here. But then they just go open up the exact same plant in maybe Vietnam, maybe in China, right? We don't want to just go, well, you saved here, but it's really just a bit of a shell game, right? And then I open up the same plant somewhere else where it's not in sight. Now, in terms of what is approved, so again, this is specific to the zero carbon world or the standard. They'll take any one of these. So the Green E-Climate, the Gold Standard, Verified Carbon Standard, Climate Action Reserve, or the American Carbon Registry. So again, the idea here is that somebody has at least paid to have a third party validate, and it's not just Will selling you carbon out of the back of my van, right? It has to be true, legitimate, right? And so by having them be certified to one of those standards, you at least have some of that. The benefit here too is that I can go across, we're working on a couple of projects now where I can easily go across all of these, and I'm still trying to find the best value for my client. I think last week I was searching for some $25 tons on legitimate confirmed projects, right? Some are as high as 250. So again, depends on what you're trying to do, but there is still value if they're third party validated. Does that make sense? On-site combustion, this is one of the bigger changes in the standard. The intent of the standard is obviously, and this is from an industry perspective, we want to ultimately electrify all heating systems so that we can clean the grid, right? It's easier than, in theory, trying to deal with 10,000 houses or 100,000 houses. We go, okay, everybody go to electric. Electricity market figures itself out. Nova Scotia Power, we're going to regulate you and go, you need to be 80% renewable. So we solve kind of two birds with one stone. The challenge with that is that Nova Scotia, specifically in Canada, is relatively oil dominant. We've always kind of have been, right? So it's harder to pull that out. The other thing, if you think about it, these guys are good examples. My house, the same thing. We use high temperature distribution. So if I want to replace that with a air to water heat pump, they don't take the same inputs. Does that make sense? If I'm used to getting 80 degree Cs and then I just give it 30 degree Cs, guess what? I'm getting a lot less heat out of that radiator, which means I'm going to call up Will and go, hey, that system you sold me doesn't work. I'm like, yeah, the distribution is high temp and I sold you a low temp distribution system, right? The idea here with the on-site combustion is not to say we need to completely remove it, but what we want to do is limit it to operate only in those coldest days. So what the standard has done is said, anytime below -15, no problem, rely on the boiler, whether it be oil or natural gas, but you still have to have a transition plan to say, how am I going to get off this when that thing ends its life, if that makes sense, when the boiler actually dies. Challenges with some also, when we look at this stuff, is regional. So the demands from a heating load in the northernmost part of Canada and say the southernmost part of Ontario or BC are vastly different, right? So understanding that some of these scenarios require, they don't have, like we looked at Nunavut, doesn't have a big central distribution grid. So I can't just go, well, I'll just use a heat pump. Probably the heat pump's not going to work at a certain point. And if the grid's intermittent, you know, I can't have that. I can't be in the middle of the night and go, well, they just turned the grid off because we ran out of diesel fuel, right? Doesn't make any sense. The transition plan again is forcing designers and owners to say, how do you get out of this? So if I'm building a new building today, ideally I'm not using high temp rad, I'm designing with low temp rad. So if my budget only allows me to put in a gas boiler, that's okay. But when that end of life is up and I want to put in an air to water or geothermal heat pump, the distribution system's already ready to take it. I'm not pulling out all the rads and redoing all the plumbing while people are still in the building. That's a real challenge. Now, in terms of the summaries around carbon, again, this is kind of a snapshot from the standard itself. So under the design and performance, under design, you must model a zero carbon balance. So that little equation I gave you, I have to model it and show, you know, if I had to today under design, how many carbon offsets in theory would I have to buy? Don't have to hit it. I just have to model it, which is forcing industry to start to take consideration, right? That's the intent. That's the first, call it ratchet, which is to go, there's impacts here that you're not considering, start considering them, right? The next step will be to ratchet that down and go, okay, let's slowly make incremental reductions in those as we go to version 4, version 5, et cetera. From an embodied carbon, you have a minimum level of performance required. So that's either a 10% reduction, which we talked about ways we could get reductions in body, or it's a maximum threshold value. So most wood construction would be under that maximum threshold value of 500 kilos per square meter. So again, first two versions of the standard didn't have a requirement. They just said, just model it and report it. Now we're seeing that number start to come down, right? Could we make that number come down faster? Sure, but Home Depot's not ready for it. Right? I don't have enough low carbon products on the shelf yet. So this is one of the things. LEED was really good at that. Have you all heard of like VOCs, volatile organic compounds, right? Low VOC paints, low VOC adhesives, low VOC sealants. LEED was preliminary responsible for that. The manufacturers go, I can market a green product and get LEED points. Yeah, we'll redo our manufacturing process. Right? It wasn't a regulatory requirement that made them change and be good people. They said, we can get VOCs down. We can do other things with our formulation. And guess what? I can market it. Is that the right way as a business? Who cares? You got the right result, which was the program slowly ratcheting things down. Refrigerants, you must report the total quantity. So if you have heat pumps, you got to know how much gas is in the heat pumps. So you got to at least know how much you've put into that thing. So if you have to do a service and they pull the gas out to do that charge check, you go, yeah, you lost. You had 100, you now only have 80, right? So we can report by understanding what we had. Renewable credits and offsets, we're not required to purchase them, but we must show that we could purchase them, if that makes sense. And then the on-site combustion, we can put it in, but it can only be used below -15, and we have to have that transition plan, okay? So this is the standard. Again, pretty streamlined, not that difficult. Performance side, you have to achieve that zero carbon balance. The benefit of the performance is all my embodied has pretty much already been accounted for, so I'm really only offsetting my operational at that point, unless I put a big addition on. I must offset any embodied carbon if I came from the design side. So it's a little loophole, right? So if I've had clients, I go, well, if I skip that and don't do this and I could go there, I don't have to pay for that. And you're like, yeah, in theory, that's not the right way to look at it, but that's true. So if I do come out of this and I want to do this every year, that first year, or I can spread it over 5 years, I would pay for that embodied carbon in offsets. Okay, so again, it's got some teeth, but it's not completely restrictive. RECs and carbon offsets, you got to provide the proof of purchase, again, trying to get out of the store without paying for the goods. And then if you do have on-site combustion, you have to update that transition plan every 5 years. What have you done to drive down energy? What are you doing to plan for that replacement? Make sense? Again, it's stepwise. We're not trying to go, everything has to be net zero energy, net zero carbon. Would not work. We just have so much pushback. Let's talk a bit about efficiency. What are we doing for time here? Okay, we're going to move a little quick, if that's okay. This is what we talked about here. This is the end of pipe, right? We want to start here with demand reduction. That's the idea of get the waste out first, right? There's no point in spending big money on a high performance heating system if I have a really cruddy building envelope, right? If I have no insulation in my wall, why would I spend $40,000 on a new heating system, right? Probably want to put some insulation in there before I even consider what high performance item I use to heat and cool the house. In the same scenario, I'm not just going to throw solar panels on if I don't have any insulation in order of value, right? The benefit of these is that they don't typically rely on gear, right? Insulation, once it's on, yes, it has an embodied carbon, but those are savings that happen as long as that insulation is on, right? So I get them every single year. That's the design philosophy. Summary of requirements. Again, from an energy perspective, they give you a couple of pathways. Gives you a flexible approach, which says meet this thermal energy demand intensity and beat the National Energy Code. Okay, that's path one. Path two is I can design to a passive standard. So anybody heard of the passive house model? It was a German standard, ultra high efficiency, heavily focused on high thermal walls, low infiltration. So you can go after that path, and they have a ramped up TEDI target. So what I would normally hit here or here, it's 10 less than that in this pathway. Not the most common path because it's a little harder to do for bigger commercial buildings. Last approach is option 3. It's renewable. So I have the same energy TEDI target as this one, but then I have to do a zero carbon balance for all operational carbon without green power offsets. So that means either on-site or virtually net metered. Okay. So again, the intent here is to provide a pathway that's flexible enough for everybody to kind of meet, and it works out. This is the one we talked about. This is the new acronym, and I don't know if they came up with this or they borrowed it and modified it from somebody else. We typically think about building envelopes as R value, right? The TEDI, or the thermal energy demand intensity, is actually all the heat loss from the building envelope and ventilation system. So to go back to the question we had earlier about the idea of heat recovery, after accounting for all passive gains and losses per unit of model floor area. So it's just a number. You know, how much energy, how many kilowatt hours do I need per square meter? And the lower that number is, the better the quality my envelope is, or the better the quality of the orientation that I've done, right? I'm taking advantage of passive solar. I've reduced the leakage through the walls, windows, and floors. That's TEDI. Now, in terms of how it's done, again, depending on where you are climatically in Canada, the number changes. So for us, we're down here, we're at zone 6. We need to hit a TEDI value of 34 kilowatt hours per square meter. So that's for that flexible approach and the renewable approach. If I went to the passive approach, it drops by 10. So same climate zone 6, I go from a 34 to a 24. Okay. That's as simple as it is. Doesn't tell me what materials I have to use, doesn't tell me how I have to build the wall. It just goes, here's the number, you model it, and you figure out how you get there, do it however you want, but this is what you need to hit. As you can imagine, the number gets higher as I get colder, and the number gets lower as I get more southerly. Make sense? Again, marries up with climatic data. Benefit of TEDI: encourages energy efficient building envelopes first. So again, looking at our pyramid, waste out, right? Demand reduction. Ensures long-term energy performance, improves occupant comfort, lowers energy bills, and improves that building resilience, right? And that's a term that popped up, and I don't think it came out of this, but it's been kicking around lately. It's called passive survivability, right? What happens if I turn the power off or I don't have oil in the boiler? What's happening to the building, right? This is probably my favorite slide. I don't know if that says about me, but this is the difference in TEDI. This was a study done in Toronto in the winter. And what they did was they looked at a couple different building types with different TEDI values. So as we saw, that was a good TEDI according to the last slide, right? 34 to 24 for our climate. So 30 here, that's a really aggressive one. These are maybe older building and a code building. And what this study looks at is what happens after 72 hours of power outage? What happens after 2 weeks of power outage? So that older building, after 72 hours, it's gone from 21 to 13.5. After 2 weeks, it's dropped down to 5.8. Now we're starting to get concerned. Number one, it's probably not livable, right? Nobody's hanging out in their house at 5 degrees. And now we're starting to look at the idea of freezing. Now, if I were to jump down and look at the 30 and the 15, again, after 72 hours, the 30 is sitting at a 17, the 15 sitting still at 19.7. So I dropped 1.3 degrees. And again, this is in Toronto in the winter, similar climate. After 2 weeks, the 30 is still sitting at 14. So again, I could probably get a sweatshirt. This is probably Ecology Action Center. You know, like, come on, guys, put an extra sweater on, right? Get your slippers out. The 15 is still at 18. So again, the value of doing good envelope, good detailing, and that idea of resiliency and passive survivability often gets overlooked because people go, I don't want to spend the extra money up front because I don't see the value because insulation is buried in the wall and it's not marble countertop. Does that make sense? Hard decisions to make sometimes. This is the Evolve One. It's a multi-tenant office building in Kitchener-Waterloo, owned by the Cora Group. So if you guys like breakfast, you probably know Cora. As you can see, this is I would say, pretty conventional or nice looking architectural building, near continuous glazing or glass in the vision zone. So we haven't taken the windows right down to the floor because my feet have no eyes. I don't have, glazing up here at 8 feet, because again, there's not too many 8-foot tall folks that I know of. Maybe you guys do. These folks were able to hit a TEDI of 24. So that's passive strategy. That's a passive house approach with what is a conventional commercial building with good design. And that's all this slide is meant to indicate. You can have a nice looking architectural building that has a really high performance envelope if you design well. Right. And I don't just go to that. That's how my dad did it, or that's how we've always done it. Right. That approach has to unfortunately die. Energy use intensity is another metric that we play with. And the EUI is the sum of all energy that occurs or consumes on site. And then we divide it by the square footage. So it's a good way to compare things. Right. So if I had 2 fire halls and I had one fire hall that was 100 units of energy per square meter and another fire hall at 50 units of energy per square meter, which one would I retrofit first? The one with the bigger, right? Same thing, if I wanted to go through and look at all the schools in the province, which ones are the worst performers? Energy per square foot, same type of building used for the same purpose. Now, would I compare a hospital to a church? No, totally different use of profile, right? Hospital is way more fresh air. Hospital runs 24/7. Church is, let's say, 2.5, 3 days a week, being very generous. So we're not comparing apples to apples. The EUI lets us do apples to apples and oranges with oranges. Provides a full picture of building energy use, encourages all type of energy efficiency measures. So it doesn't matter if it's envelope, lighting upgrades, occupancy sensors, whatever it happens to be, they all impact EUI. Allows for future comparison between modeled and actual performance. That's the other thing, it's one thing to do a project, but if I don't continue to track, guess what happens? I start to bleed savings, right? So being able to do something and go, here's the validated, I ran it, here's a number. Well, if I see that starting to track up, it tells me something's out of whack. Maybe my heating systems, maybe Chris snuck in and turned the heating set point up to 24 instead of 21 that I set it at, right? We start to get that little bit of garbage in or the waste. So tracking the EUI month after month tells us, are we performing to baseline, or are we slipping in performing worse, or are we slightly getting better? Does that make sense? In terms of some reduction measures for EUI, efficient systems, heat pumps, variable frequency drives. So things that reduce input, give you the same output. Energy recovery, ERV, energy recovery, or HRV, heat recovery ventilators, wastewater heat recovery, passive strategies, orientation, and selective glazing. Pretty hard to move a building once it's built, but we can pick different window types that allow or do not allow solar energy in. Load reductions, things like replacing light bulbs. So this is a good example. This light bulb probably doesn't get used too much, but that's ancient, right? Probably there for the Christmas pageant or play, right? Runs 5 hours a year. Now, if that ran 24/7, I would definitely flip that out for an LED, right? That's load reduction. Insulation, again, gets it out right out of the case. This is the Mohawk. This was a Mohawk College brand new Joyce Center for Partnership and Innovation academic building done in Hamilton, Ontario. They did zero carbon design, and then after 12 months, they went into the performance. Under that, they had set an early EUI target of 73 kilowatt hours per square meter, which is pretty low. Most of what we would call to designing to net zero ready today is 100 kilowatts per meter squared. So they set a budget less than what we call net zero ready. They prepared an energy budget to measure in performance. I actually had one of the project participants in one of my classes, and they said they've still been tracking it, and they actually beat the 73, and they've subsequently improved it through occupant behavior, right? So a little bit of education. Hey, Chris, sorry to keep picking on you, Chris. Hey, Chris, do you mind flipping your light off when you leave after, if you're not going to be in here, do you mind turning your thermostat down, right? We can make the nicest buildings with the nicest systems, but as soon as we throw the variable of a human in it, right? It's like playing dice, right? My wife likes it extremely hot. My kids, same thing, I have a daughter who would take a 25-minute shower if I don't flick the light and say, time to get out, right? But the reality is that we all have our preferences, and we're not all wired to think about it the same way maybe I think about it. The last piece here, and I think we're probably gonna be all right here. Peak demand. For those of you who don't, again, live in the energy world, peak is the highest electrical load requirement from the grid, and it's reflecting any peak shaving impacts from demand management strategies, including on-site renewables, battery storage, or thermal storage. So for those of you, we all think about kilowatt hours, right? It's how much I pay the bill, how many circles the meter used to go around. The demand is more equivalent to like a hose. Does that make sense? So if my kilowatt hours were how much water's in the bucket, my demand is how fast I fill the bucket, right? So the grid or Nova Scotia Power is only concerned with how fast you pull, and they look at it from a business perspective, how fast you pull over a 30-day period. So if I were, I don't know, maybe I was a Michelin, and as soon as I turn on, as you can imagine, I turn on all that gear in 1.6 million square feet, what's going to happen? I'm going to light that grid up, right? My peak's going to spike. Now, instead, if I had gone in and said, okay, I want to turn this piece of gear on, go in, have a coffee, and then I'm going to turn this piece of gear on, have another coffee, I'm going to turn this gear on, right? Instead of having this huge peak, I've created a bit of a level, right? So Nova Scotia Power goes, well, they don't need this huge amount of power at once. They need kind of this steady profile, right? And in an ideal world, we all drew on a steady demand profile would make Nova Scotia Power's job much easier because they don't have to worry about turning on quick dispatchable peak load assets, right? And those peak load assets typically have a higher cost per unit, right? So that's when we talk about some of what goes into how does my electricity at home end up equaling 16 cents? Well, it's a bit of base load plus a bit of peak response plus a bit of fuel adjustment mechanism plus a little piece for our friends over at Efficiency Nova Scotia, right? All that number gets aggregated and blended. Why do we bother managing peaks? Improves reliability. I think we saw this, I want to say it was 4 years ago, brownout. I think it hit the States and then it hit Ontario and kind of hit that horseshoe. When the grid goes imbalanced, it's a hard one to correct. Reduces marginal emissions from peaking power plants. Again, the peaking power plants in Nova Scotia are gas, which are cleaner than the coal fire. So we're a bit backwards. Now in Quebec, if I had a peaker that was gas versus my hydro, the peaker plant would have a worse emission factor when I turn it on. Does that make sense? So depending on what the generation assets are in the province or in the region, depends on which one my average or my base load versus my marginal, i.e. the next piece of equipment I turn on. Improves resilience to shock. The biggest piece here that this is gonna have an impact, and I'll use Nova Scotia as an example, is let's say everybody in this room did a great job, listened to Will. They flipped all their heating and cooling, their whole houses, all the buildings they owned were now all electric. And every car that we drove here in was now, tomorrow, electric. Do you think the old tired Nova Scotia power grid is ready for that? No. We're going to need to get smarter about how we manage demand. So something like this, and I'll use Sobeys as an example. I don't want to turn off the cases to the ice cream freezer, right? But I could turn off the case to the sandwich cooler if I had to for 15 minutes, right? That idea of understanding non-essential versus essential loads and saying, well, if I set you a budget, Sobeys in New Glasgow, as soon as you start to creep up to that kilowatt budget, if I ask you to turn off some stuff to keep you from leveling there, now this is easier. I can bring your rates down, right? That's where we're going to ultimately end up going. So for example, Nova Scotia Power did a battery pilot. I have one in my house. We did a similar project in Berwick. Nova Scotia Power actually discharges my battery between 5 and 7. So because I got a great deal on it as part of the pilot, I'm okay paying that bit of energy. But when they turn that battery on at my house, they've just turned on 5,000 watts of power, which means they don't have to supply 5,000 watts of power. So again, this idea of distributed energy with smart grid interaction is where we are ultimately going. So that idea of going, maybe I was pulling 10,000 from Nova Scotia Power, but I fired the battery, or maybe it's a battery that's owned by the subdivision, right? Subdivisions fired the battery. That's where we're going to ultimately go, because to fix this or to do the things like the Maritime Loop, those are billions and billions of dollars with massive timelines, right? Look at the Lower Churchill project, for example. Massive potential to bring hydro. It's overdue by about 2 years, right? Reduction measures for peak, scheduling, turning stuff off that doesn't need to be on, shrinking. So again, optimizing something like a heat pump. Heat pump puts out the same amount as that baseboard was with a third of the input, right? So that means that that peak demand goes down. Shaving, electrical or thermal, on-site power generation or on-site renewable. So the batteries we did in Berwick, the big commercials, that's exactly what they do. As the town of Berwick's grid starts to climb, we have a bit of machine learning or AI that goes, is the weather getting bad? We've taken the readings from our friends at Environment Canada. Do I need to discharge this to keep that total pull from Nova Scotia Power down for the town? Because the town pays for that all year round, right? So that's pretty significant savings for them. The same piece here we could do with thermal storage. We don't think about that a lot, but rather than just turn the baseboard on anytime the room needed a little bit of heat, what if we had a hot water tank that we could turn off in off-peak times? Have it sitting on reserve. I got some nice warm water. You need some heat for the room? No problem. Let's take it out of the tank, right? So again, thermal storage and electrical storage will become more and more normal, and the price point will start to drop. But it will be one of those things that we ultimately will all see in our house or in our business easily in the next 5 to 10 years. Air tightness, again, one of those ways to reduce demand. But if I have, let's say this wall and this wall are, I don't know, maybe those are R60 walls, really good. Maybe I got a super impressive Teddy value from my model, but I didn't do any of the air sealing. R value doesn't mean anything if I've got air moving from outside to inside uncontrolled, right? So that idea of tight and getting those details right. And as an industry, we don't do a great job of that. I used to own an insulation company, Thermo Homes, and it always blew my mind because they go, call it the lowest paid person on the job who was doing the air sealing and the vapor barrier was doing one of the most important jobs for the building envelope. You're not paying these folks as professionals. You're not paying them to do the best job they can around that window. At the end of the day, sorry, that's my daughter. She keeps calling. Probably wants her car back. But at the end of the day, if we're not controlling both the air as well as the thermal across the insulation, again, doesn't matter how good the heating system is or how many panels we have, we're being wasteful. Summary requirements for energy. Under the zero carbon V3, we must meet one of the 3 standards, which I talked about was that flexible. That's 25% better than the code, plus hitting the Teddy target. There was the passive approach, which was the much more aggressive building envelope. And then there was the renewable approach, which was same Teddy value as the flexible, but now I have to meet all operational carbon with on-site or virtually net metered. Air tightness, I must report and justify the value. From a performance side, I just have to report the EUI. I report my seasonal peaks, my heating and my cooling seasonal peaks from an energy demand, and I conduct air testing on my actual building envelope if I'm coming from the design side. So if this church was to be going down the performance path, we never came through this design side, so all we would have to do is go get our 12 to 24 months of data. We would put that in the workbook. We would say, this is how much operational carbon it is. We go, we're either gonna buy that through a power purchase agreement or a carbon offset. We could meet that relatively easily. And that's why this standard is so simple, right? And you're seeing a lot of this. GICB, Green Inclusive Community Buildings, which is a fund the feds have put together. They actually, after the first round, said, okay, the pathway to certify to meet to get funding as a non-for-profit, as a community organization, as a social enterprise is meet zero carbon. They said there's lots of ways to do it, but this makes it easy for them to go, if you can prove this and you can certify, no problem. That's your funding approval checkbox. We can release dollars into your project. Last little section, this is impacting innovation. Again, the intent here is to incrementally get better. And the impact in innovation is really about saying, you know, business as usual has to change to some extent. We have to allow a bit of the mad scientist, right? So we have to try things that sometimes maybe we're not totally comfortable with, but if we don't try them, we don't know if they work or they don't work. And the CAGBC is not that risk tolerant. So they've come up with a list of things that they can do. On-site renewable. If you can do enough on-site renewable to offset 5% of your building, that's considered innovative because most buildings aren't doing it. Building integrated photovoltaics. So this is actually, maybe my cladding is a panel. Maybe my window is now a panel. This one to me is a bit of a, I'll call it a scapegoat. I only need one panel. So even if I did the one glass on the north side, which is never going to make any electricity, that would in theory qualify. That's innovative, right? Electrification of spacing or hot water. This is by far the one that we're doing the most of, right? All of our designs, all the projects we're working with is zero carbon. That's the first piece. We're going, we're not putting in combustion systems here. What do you want? Do you want geothermal? Do you want air to water? Do you want air source? Reduction in embodied carbon. If you go further than the 10%, that's one of them. Or electric or thermal storage. So projects must pick two of these. Okay, so under the carbon, we had to do what we saw on the table, under the energy, and then I have to pick two of those. That's the whole requirement of the zero carbon standard. And again, whether I'm design or performance, they pretty much follow suit. Does that make sense? I'm not going to get into certification because we're a little over time. And unless you're certifying, if you do, I'm glad to give you one of my cards and I can point you in the right direction, but it's pretty dry stuff. Wonderful.
Thank you very much.
You're very welcome, Helen.
Just before I thank you properly, I just want to remind people that we're not here next week, but we'll be here on the 14th. And Chris told me there's going to be an electric car coming on the 14th
nice.
too.
Yeah.
Pardon?
We hope.
Oh, well, we all have to hope. So you people at home, we'll just have to feed to you later what we found out. Again, thank you very much, Will, for coming today. A lot of information to absorb. Thank you to people for asking questions. Questions always help us remember and to take or lead our mind in the direction we might not have been going. Thank you for your time.
You're very welcome. Appreciate it. Thank you. There you go.